In this video, we are going to learn how to make a graphical representation of the evolution of the most important variables along time. These graphs are known as strip charts. You must select the strip chart folder on the menu and click on the Add button. This generates our first data strip chart, data logger 1. Now we need to add the selected variables. Click on the Add button. I'm going to define a first strip chart including the most important molar flows of the process. I select the propylene oxide mass flow. This one. I add this variable to the graph. I am also going to include the water feed stream, mass flow, add. The reactor products stream, mass flow, add. And finally, the reactor vent. This is an almost zero stream, molar flow stream, that only accomplishes for changes in the liquid level of the reactor. Add. Now I have the 4 mass flows. Click on Done, Display, and this is the new strip chart. This strip chart has many different options. I will show you the most relevant ones. Right click on the black area, select Graph Control. The first one recommendation is to delete the background for a light graph. Click on the setup logger. This is the number of points recorded of these variables for the representation. 300 is a low value. I recommend you to increase it, for example, to 3000 values. In the second tab, Curves, you must review the colors used for the graphs. If they are very light, please use dark ones. This one, this is okay. And finally, in Access, the recommendation is to use automatic auto scale. Now, if you run the simulation, no assistant, these are the represented molar flows of the different variables. Here at the bottom you have the blue bar indicating the number of recorded points, and the range between this red and this yellow flags represents the data which are represented in the graph. The recommendation is to move this red flag, this limit, to the full left size, so that the 3000 points which are recorded are included into the graph. If more than 3000 points are calculated, the first one will be deleted and forgotten, and the new ones will be incorporated on the left. Now, any change, for example, you see that there is not too much stable system, probably because of the reactor temperature control, which is not very efficient. If I change now temperature, for example, to 55, let's say, for example, 70 degrees, there is almost no change. You can appreciate in the system. The system is much more stable at a higher temperature because of the cooling. If I change, for example, the reactor level set point from 50 to 70%, now, initially, the reactor products is closed until the liquid of level reaches the recommended the setup value, and now the value goes again to the steady state system. Okay, this is all. Only a second graph, just to show you again and to practice with this. I'm going to create here in strip charts a new data logger. In this one, I'm going to represent values corresponding to the reactor. I'm going to represent, for example, the level, the liquid percent level, and also, for example, temperature, which is a critical variable, the vessel temperature. done, display, and now once again I change the setup the options. I delete the background, I change the setup logger to 3000. I'm going to review the curves, light blue, I prefer dark blue, and red is okay, and in access I select the automatic auto scale. I'm going to show this graph on the right side. I'm going to represent here the diagram, and I'm going to view also the second data logger. Okay, display. Where is this data logger? View. Okay. I want to see this one. Windows. Data logger 1. I don't know where is this data logger hidden in the screen. Okay. Oh, here it is. Okay, now I have data logger 1, data logger 2. I start the simulation now. And now you can see the evolution. The system is stable. I'm going to change temperature, for example, to 62. You can see the evolution of temperature, the evolution of the level, and how long times I need to increase also the representation range in this graph. Okay, and this is all. Practice with your system.